A particulate representation of the reactants is shown below in the box on the left. In the box below on the right, draw the particulate representation of all the molecules that would be produced from these 4 reactant molecules. Visual. 1 point is earned for correctly representing products as H₂O and O₂ molecules. 1 point is earned for atom balance. Shown below is a potential energy diagram for the uncatalyzed decomposition of H₂O₂. Visual. 1. According to the diagram, is the decomposition reaction exothermic or endothermic? Justify your answer. 2. Manganese dioxide, MnO₂, is an insoluble substance that acts as a catalyst for the decomposition reaction. On the diagram above, draw a curve to represent the reaction as it occurs in the presence of MnO₂. 1. This reaction is exothermic because the products have lower potential energy than the reactants. Thus, the system has lost potential energy, releasing heat. 1 point is earned for indication that the reaction is exothermic, with a valid justification. 2. The curve for the catalyzed reaction has the reactants and products at the same energy levels as the original curve and a lower activation energy than the original curve. 1 point is earned for a correct curve. A student investigates the decomposition reaction in the laboratory. The student prepares 2 small beakers, adding 20.0 milliliters of 9.77 molar H₂O₂ to each one. Each beaker is placed on an electronic balance. The student adds 0.10 grams of MnO₂ to the second beaker and records the mass of each beaker and its contents at 10-second intervals for 1 minute. The beakers and the data are shown below. Visual. 1. The number of moles of O₂ that was produced. 2. The mass of H₂O₂ that decomposed. 1. Mass O₂ equals 43.19 grams minus 42.58 grams equals 0.61 grams. Moles O₂ equals 0.61 grams O₂ times 1 moles O₂ / 32.00 grams equals 0.019 moles O₂. 1 point is earned for the correct answer. 2. Mass H₂O₂ equals 0.019 moles O₂ times 2 moles H₂O₂ / 1 moles O₂ times 34.02 grams H₂O₂ / 1 moles H₂O₂ equals 1.3 grams H₂O₂. 1 point is earned for the correct answer. The student continues the experiment for an additional minute. For beaker 2, will the mass of H₂O₂ consumed during the second minute be greater than, less than, or equal to the mass of H₂O₂ consumed during the first minute? Explain your answer referring to the data in the table. Less than. The decrease in mass becomes smaller over every subsequent 10-second interval. This decreasing trend would continue in the second minute. 1 point is earned for the correct choice with a valid explanation. Based on the data, the student claims that the catalyzed reaction has zeroth order kinetics. Do you agree with the student's claim? Justify your answer. Disagree. If the reaction were zeroth order, the rate of mass loss, which corresponds to the rate of reaction, would be constant until the reactant was consumed. However, the data show that the rate of mass loss from beaker 2 is not constant. 1 point is earned for disagreement and a valid justification. A second student did the experiment using larger volumes of 9.77 molar H₂O₂. The student noticed that the reaction in beaker 2 proceeded extremely rapidly, causing some of the liquid to splash out of the beaker onto the lab table. The student claims that as a result of the loss of the liquid from the beaker, the calculated number of moles of O₂ produced is greater than the actual number of moles of O₂ produced during the first 60 seconds. Do you agree with the student? Justify your answer. Agree. The calculated amount of O₂ produced is based on the change in mass, and in this case, some of the change in mass is due to loss of solution rather than production of O₂. 1 point is earned for agreement and a valid justification. The hydrogen peroxide used in this experiment can be prepared by the reaction of solid ammonium peroxydisulfate, NH4, 2S2O8, with water. The products are hydrogen peroxide, H₂O₂, and ammonium bisulfate, NH4HSO4. Write the balanced equation for the reaction. NH4, 2S2O8 plus 2H₂O gives H₂O₂ plus 2NH4HSO4. Or, NH4, 2S2O8 plus 2H₂O gives H₂O₂ plus 2NH4 plus 2HSO4 minus. Or, S2O8 2 minus plus 2H₂O gives H₂O₂ plus 2HSO4 minus. 1 point is earned for a correct balanced equation.